Today we're going to look at limits using analytical techniques, and we're going to concentrate on the theorem functions that agree at all but one point. Now, we've discussed the theorem previously. We know what it says. Let's actually see how it works in practice. So let's look at a problem. Let's say we wanted to look at the limit as x goes to 1 of x squared minus 1 over x minus 1. First, we know we can't evaluate this limit via functional evaluation because the denominator is undefined at 0. Undefined at 1, namely the denominator is 0. First, let's observe that we cannot evaluate this limit through functional evaluation because the denominator, when evaluated at 1, is 0. Namely, you would have a 0 in the denominator. Also, we observe immediately that the numerator is 0 as well, which is good because this tells us that we have more work to do in terms of determining whether the limit exists. So, let's factor. Since we know 1 is a factor, since we know x minus 1 is a factor of the numerator. Okay. Now, we're going to cancel in the limit. And this would be a 1 in the denominator. So let's look and see what we get. So this would be the limit as x goes to 1 of x plus 1. Okay, now, clearly this is a polynomial. X plus 1 is a polynomial. So this limit can be obtained by functional evaluation. Namely, we can just plug in the 1 for x, and we get an answer of 2 for the limit. Now, the question is, why is this limit equal to this limit? This is the question. And of course, the answer is because these two functions agree at all at one point. The original function of x minus 1 times x plus 1 over x minus 1 is equal to x plus 1 is equal to so in other words, f and g agree, i.e. they're equal, at all values except equal 1. In other words, they agree at all but one point, namely x equal 1. Since f and g agree at all but one point, they have the same limit if the limit of g exists, which it does. So the limit as x goes to 1 of x plus 1, which this is the limit as x goes to 1 of g of x, that limit's 2, therefore the limit of the original function is 2. So to finish the statement in the space remaining, we have shown that the original problem, the limit as x goes to 1 of x squared minus 1 over x minus 1 is equal to 2.